Hi and welcome to PA Academy. This is the part 7 of the video series Quadratic Equation. So in this part 7 we are going to be looking at symmetric property of the root. So when we talk about the symmetric property of the root, from the definition I said this shows the relationship between the root of a quadratic equation and the quadratic equation itself. So that means in any quadratic equation there is always a relationship between the quadratic equation itself and the root. That means the value of x of that quadratic equation. It says if alpha and beta are the root of a quadratic equation, so and a is the coefficient of s squared, b is the coefficient of x, and c is the constant. That's this quadratic equation. If you watch the previous part of this video, you understand what this means: as squared plus bx plus c. So this is also a quadratic equation. This a, b, and c, they are representing numbers. So he said if the alpha and beta are now the roots of the quadratic equation, that means after solving any quadratic equation, the value of x, or what you get as the root of that quadratic equation. So let's assume it is alpha and beta. So he said then alpha plus beta is equals to minus b over a. So what it means is that by the time you add the value of the roots of any quadratic equation, it will give you, it will be the same thing as minus b over a. Minus b over a is the negative of the value of the coefficient of x, which is this b, over the coefficient of x squared. So also if you multiply the roots of the quadratic equation, it will be the same thing as having c over a. If it's not clear, I'm also going to let me use this example. So this is one of the example we solved in previous part of this video. Now if you look at this quadratic equation, let me write it out. This is the quadratic equation: 2p squared minus 33p plus 16 is equals to 0. Now for this quadratic equation, the answer we got for the value of p, or you can also call it the root of that equation, we got our p is equals to 16 and our p is equals to 1 over 2. Now let's now look at what's relating it to symmetric properties of roots. So now let's represent the alpha as 16, and let's say the beta is equals to 1 over 2. So now we have this alpha plus beta is equals to minus b over a. First of all, let's bring out the value of a, b, and c from this quadratic equation. So from this quadratic equation, the value of a is 2, which is the coefficient of p squared, and that of b is minus 33. And then the value of c, which is the constant, is 16. So now let's apply what this thing is saying from the symmetric properties of roots. It says alpha plus beta is also equals to minus b over a. Now using this quadratic equation to explain what that means. So alpha is 16 and our beta is 1 over 2. So let me write the formula here. It said alpha plus beta is equals to minus b over a. So let's look at it. Alpha plus beta, that is 16 plus 1 over 2. So that will give us 16 and a half. So that will give us 16 and a half. Now let's look at minus b over a. What will give minus b over a will give us? So minus b over a, so that will be minus, what's the value of b? This is the value of b, minus 33. Let's put that into brackets, minus 33 over, what's the value of a? 2. So that will give us minus 33 minus 33, that will give us 33 over 2. So 33 divided by 2 will give us 16 and a half. So you can see that if we add minus, we have 16 and a half here, we also have 16 and a half. So this is alpha plus beta. So that means for a quadratic equation, by the time we add the roots of the equation, of that quadratic equation, it will also be the same thing as minus b over a. So sometimes you can also use this to check if you are correct when solving quadratic equation. So I'm going to use another example that we solved earlier in the previous part of this video. So using this one to also explain symmetric properties of roots. So let me write out the quadratic equation. Here we have x squared plus 5x plus 6 is equals to 0. So the answer to this when we solved it was, we got our value for x. Our x is equals to -2 and our x is equals to -3. So now let's check if this also applies. So first of all, let's bring out the value of our a and b and c from this quadratic equation. So from this quadratic equation, our a, which is the coefficient of x squared, is 1. So there's no number here, it's always 1. There's always 1. Once there's no number here, there's 1, but we don't need to write it because it will still be x squared. So the coefficient of x squared here is 1. And then for b, which is the coefficient of x, is 5. And then c is the constant, which is 6. So we've gotten the value of a, b, and c. So now let's see if alpha plus beta and then is also equals to minus b over a. So let's see. So alpha, first of all, let me write the value for alpha. So let's take our alpha to be equals to -2. And our beta should be -3. This -3 here, take it as our beta. This -2, we take it as our alpha. So by the time we add it, alpha plus beta, that will equals to -2 plus -3, which is -2 minus 3, and that is equals to -5. So alpha plus beta is -5. That's the addition of these two roots of this quadratic equation. -2 and -5 and -3 will give us -5. So now let's check if it is also the same thing if we have minus b over a. So minus b over a. So the value of our b is 5. So that will be -5 over, and our a is 1 over 1. That is equals to -5. So you can see the relationship between the root and the quadratic equation itself. So alpha plus beta, which is the root of the equation, by the time we add it, is also the same thing as having minus b over a, picking it from the quadratic equation itself. So then let's look at the second one also, where we have alpha multiplied by beta is equals to c over a. So let's look at this also. So alpha multiplied by beta, so the value of our alpha is I've written it here, is -2. So -2 multiplied by, and our beta is -3 multiplied by -3. Don't forget, this -2 and -3 are the roots of that quadratic equation, this quadratic equation. So -2 times -3, that will give us 6. So let's also look see if c over a will also give us 6. So c over a. So the value of our c is 6 and the value of our a is 1. So let's substitute it. So the value of our c is 6 and the value of our a is 1, which is equals to 6. So you can see that we arrive at the same answer. So that's just to show you that when we talk about the symmetric property of roots, we are showing the relationship between the quadratic equation itself and the root of that quadratic equation. So these two are what prove that symmetric property of the roots. So in the next part, we are going to be using this. We are going to be looking at examples that deals with symmetric properties of root. There are some questions that under quadratic equation whereby you are going to use some of this formula. Okay, before we even solve example, I'm still going to show you some other things in the next part of this video. So I'll see you there. So if you are here to subscribe to this channel, kindly click on the subscribe button to subscribe to this channel. So please make sure you like and share this video, and if you have any question, you drop it in the comments below, and I'll see you in the next part of this video.